So here are the solutions for Cedar 1. If you haven't already, have a go at filling in section C so that you can see where you lost most of your marks. Is it because you've been too fast and you're not getting all the arithmetic correct? Is it you're making silly mistakes with your algebra, etc.? Okay. First question in section A, which type of mapping is shown here? And we've got a graph and we've got 4 different types of mappings. So hopefully you can spot it's definitely not one-to-one. And if I pick 2 points, look, both those points have the same output but different inputs. So it's many to one. So which is the solution for 2 to the power x equals 7? So to get rid of the base, the inverse of the base is log. So I would do log 2 on both sides. On the left hand side, the log 2 and the base 2 cancel. So I just get x equals log 2, 7. So it was B. Okay, third one. If 3x equals y, then what's 3 to the power 5x plus 2 in terms of y? Well, first thing is, if there's a plus in the power, when I split it up, it turns into a times. And 3 to the power 5x, I can write that as 3 to the power x to the power 5 times, well, 3 to the power 2 is 9, and 3 to the power x is y, so it's y5 times 9, so it's 9y5. F of x is 1 over x, g of x is 1 over 3x. G of x can be written in terms of f of x in 2 different ways. Which pair has both correct expressions for g of x? Well, 1 over 3x, that's g of x. I can think of that as subbing in 3x into 1 over x. So I can think of that as f of 3x. Secondly, I can think of it as, well, 1 over 3x is the same as 1 over 3 times 1 over x, and 1 over x is the same as f of x. So I can think of it as the third f of x or f of 3x, so it's the same as c. Now, if you couldn't spot that, I guess you could always try subbing in the expressions and see what happens. So if I was doing f of x over 3, I would get 1 over x over 3, and if I times top and bottom by 3, I would get 3 over x, and that isn't the same as g of x. And the other one was 3 f of x, which is 3 times 1 over x, which again gives me 3 over x, which isn't what I'm trying to get. So if you can't spot the answers, you can always eliminate answers. Number 5, expand and simplify. So I would do the powers first, so I'd expand that first. So I'm going to leave that alone. And x plus 2 squared means x plus 2 times x plus 2. So I'm going to get an x squared. I'm going to get 2 lots of 2x's, so that's 4x. And I'm going to get 4 at the end. Plus 3x minus 1 times 4x cubed plus 2x squared minus x plus 6. Now, I'm just going to expand them now. So if I just do this first one, let's call this the blue one. So first of all, I'm going to times them by x cubed, so like x5 plus 4x to the power 4 plus 4x cubed. And I'm going to times them by minus 3, so minus 3x squared minus 12x minus 12. Then I'm going to simplify that bracket. to get x5 plus 4x4. Actually, in fact, it's already simplified. I don't have to simplify that anymore, can I? So I'm just going to expand by that 2 to get 2x5 plus 8x4 plus 8x cubed minus 6x squared minus 24x minus 24. Then if I do this one in green, so I'm going to times everything by 3x first, so 12x4 plus 6x cubed minus 3x squared plus 18x, and now times everything by minus 1, so minus 4x cubed minus 2x squared plus x minus 6, and simplify it, so I get 12x4, 6x cubed, take away 4x cubed gives me 2x cubed, minus 3x squared minus 2x squared gives me minus 5x squared, 18x plus x gives me 19x, and then minus 6 at the end. So that's my final answer for the second part. That was my final answer for the first part. And I'm just going to add them together to get 2x5 plus 20x4 plus 10x cubed minus 11x squared minus 5x minus 30. So the functions f and g are defined by f of x is x plus 1. And this bit here is just tell me what x can be. That is, x can be any real number. And g of x is x squared minus 9. And this is tell me what x can be. It's in x is any real number. So for part A, find fg of x in terms of x and state its domain and range. So fg means I'm going to sub in g into f. And g is x squared minus 9. So I'm going to put that inside f. So it tells me x squared minus 9 plus 1. And I simplify that to get x squared minus 8. Now, domain and range means what inputs and outputs can be put in. Well, if I think of this as a graph, x squared minus 8 would be quadratic. The domain would be the x values, so x can be any real number. And the range would be the y values, so fg of x, well, it's anything from this number upwards, because that's the minimum. And the minimum, you can see, is minus 8, so it's bigger than or equal to minus 8. Solve the equation fg of x equals 0, so x squared minus 8 equals 0, so x squared equals 8. Square root both sides, and remember when I square root, I get a plus or minus. And I guess you could simplify that if you want into x equals plus or minus 2 root 2. Seven, find the inverse function of that function there. So remember, I call the inverse any letter, so if I just call y equals the inverse of x, apply f to both sides, I get f of y equals x. So if I sub y into f, I get a third times 2y minus 5 equals x. I'm going to times both sides by 3. I'm going to add 5 to both sides and divide both sides by 2. And y was the inverse, so therefore the inverse of f is 3x plus 5 over 2. 8. I've got the diagram of y equals x squared times x minus 4, that's my green graph, and y equals 5 over x, that's my blue graph. Explain why there are two real solutions to that equation there. Well, if I've got this equation, to find out how many solutions there are, I could draw those graphs, or if I try and rearrange it into the graphs I'm given, I can use those graphs. So if I divide both sides by x, I get x squared times x minus 4 equals 5 over x. And this equation has two real solutions as the graphs intersect twice. So since that equation has two solutions, my original equation has two solutions. Solve that inequality. Well, to solve inequality, step 1 is to solve if there was an equal sign there to get my critical values. So if I solve it, I get x minus 6, x minus 2 is equal to 0. So x is 6, x is 2, they're my critical values. So that means that's going to be the boundary of my regions that work. Then if I draw the graph y equals x squared minus 8x plus 12, if I do that in green, that's going to look like u. And if I draw y equals 0, that's just going to look like my x-axis. And they cross at the points 2 and 6. Now the inequality says when is green bigger than or equal to red. Now the graphs can be split, or the x values can be split into three sections. I've got this section here before 2, I've got this section in the middle, and this section after 6. Well, if I look before 2, green is bigger than red, so that works. If I look after 2, green is less than red, so that one doesn't work. Then if I look after 6, green is bigger than red again, so that works. So I've got two inequalities, so I can write that as x is less than or equal to 2, or x is bigger than or equal to 6. Now, in maths, we try not to write too many words, so we can use set notation. So x, the set of x's where x is less than or equal to 2, or the set of x's where x is bigger than or equal to 6, and the symbol we use for or is that U kind of shape. Equally, you can write it using interval notation, so that first one goes from minus infinity to 2, and it can equal 2, so square bracket, or from 6, and it can be 6 square bracket, all the way to infinity. 10. Well, I'm trying to find y, so that 9 to the power y plus 1 is 27 to the power 2y minus 1. So the first thing I need is the same base. So 9 and 27, I can write those both as base 3. So I can write 9 as 3 squared to the power y plus 1, and 27 as 3 cubed to the power 2y minus 1. The rule is I can multiply the powers, so 2y plus 2 and 6y minus 3. Now I can remove the base 3's by doing log base 3 on both sides to get 2y plus 2 is 6y minus 3. Take away 2y from both sides and plus 3 to both sides gives me 4y equals 5, and divide both sides by 4 gives me 5 over 4 for y. So we got a sketch of the graph y equals f of x. I don't have the equation though. I've got the points a, b, c, d on that curve. And part A asks me to sketch the graph of y equals f of x, 3f of x, and give the coordinates of a, b, c, d. So if I'm timing it by 3, then I want to have that 3 touching either the x or the y. So if I divide both sides by 3, I get y over 3 is f of x. So y has been divided by 3, so that means it's a stretch. And it's in the y direction, so it's a vertical stretch. And the scale factor, well, we do the opposite, so it's going to be 3. So when I sketch my new graph, the shape's going to be the same. It's just going to shoot up by a factor of 3. So let's look at the coordinates. So A is not going to be 2 anymore. It's going to shoot up by 3. It's going to be 6. B is still going to be 1. C is going to be 4, but then the Y coordinate is going to shoot up by 3, so it's going to be 12. And D is still going to be at 6. B is asking for finding the equation of the graph obtained from y equals x squared minus 3x plus 1. So it's a new graph when it's translated in the positive y direction by 4 and then stretched by a factor of 2 on the y-axis. Well, first of all, translated in the positive y direction by 4. So it's, if I call my f of x squared minus 3x plus 1, then I can write using my transformation knowledge. Translation is plus or minus, and it's going to be next to y. Now it's positive 4, so I do the opposite when I write it next to y, so it's minus 4. It's stretched by a scale factor 2 in the x direction, so that means it's going to be next to the x. Stretch means it's times the divide, and I do the opposite, so it's going to be a half, because that's the same as dividing by 2. So I'm going to sub in a half x into my function, so I get y minus 4 is a half x squared, take away 3 times a half x plus 1, and then just simplify it to give a quarter x squared minus 3 over 2x plus 1, and then add 4 to both sides. So y equals a quarter x squared minus 3 over 2x plus 5. Okay, section B. So we're going to solve that equation. So to solve equations, we need to factorize. So I'm going to think of x minus 1 as a. Now, if it helps, you can change it to a letter a, and x plus 2 as b. So I can think of it as 15 a4 b6 plus 10 b5 a5 equals 0. Yeah, this is what you can do if you're not confident with the brackets. Now, if I look at numbers 15 and 10, I can take out 5. I've got A4 and A5, so I can take out 4 A's. I've got B6 and B5, so I can take out 5 B's. And I'm left with, well, the first bracket, I've got 3 to get 15. I've got all my A's, but I need one more B to make B6. To get the 10, I need 2. I've got all the B's, but to get A5, I need one more A, like that, and that equals 0. And now I can just sub in what A and B were. So 5 lots of x minus 1 to the power 4 times x plus 2 to the power 5 times 3 lots of x plus 2 plus 2 lots of x minus 1 equals 0. Now I'm going to expand and simplify that square bracket. So I get 3x plus 2x is 5x. 6 plus minus 2 is 4. And then if it equals 0, well, x minus 1 equals 0 means x equals 1. X plus 2 equals 0 means x equals minus 2. And 5x plus 4 equals 0. I would take away 4 from both sides to get 5x is minus 4. Then divide both sides by 5 to get x equals minus 4 over 5. Question 2. Solve x over x plus 4 plus 7 over x minus 2 equals 1. Well, I'm going to need a common denominator. So a common denominator would be x plus 4 times x minus 2. The first fraction, I've already got the x plus 4 in the bottom, so I need to times the bottom by x minus 2, so I need to times top by x minus 2. The second fraction, I've already got the x minus 2 in the bottom, so I need to times bottom by x plus 4, so I need to times top by x plus 4, and once they have common denominators, I can just add the tops. And if I expand and simplify the top, I get x squared minus 2x plus 7x plus 28 all over x plus 4, x minus 2 equals 1. Then I don't like having the fractions, so I can times both sides by x plus 4, x minus 2, get x squared minus 2x plus 7x plus 28 equals x plus 4, x minus 2. Now I'm just going to simplify both sides. Well, on the right hand side, I'm going to expand and simplify. So I get x squared plus 5x plus 28. On the right hand side, I get x squared plus 2x minus 8. And I can take away x squared from both sides. I can take away 2x from both sides. And I can take away 28 from both sides. Get all the x's on one side, all the non-x's on the other side. So I get 3x on this side. And on the other side, I get minus 36. Divide both sides by 3, and I get x equals minus 12. Show that can be written in the form c times root d over 10, where c and d are integers, and integers mean whole numbers. Well, the first thing I'm going to do is I'm going to rationalize both of them. So the first fraction, I'm going to times top and bottom by root 5. And the second fraction, I'm going to times top and bottom by root 10. So for the first one, I get 2 root 30 over 5, take away root 30 over 10. Now to take them away, I need a common denominator. So let's get a common denominator of 10, 5 and 10. So the first one, I need times the bottom by 2 to get 10. So I need times the top by 2. So 4 root 30. Take away root 30. And I've got 4 root 30s, take away 1 root 30. That leaves me with 3 root 30 over 10. So C is 3, D is 30. And then the last one, 4 to the power x plus 1, take away 9 times 2 to the power x plus 2 equals 0. Well, I can't simplify any of those terms, so that especially that middle term, you might be thinking we can write that as 18 to the power x. We can't. If it was 9 to the power x times 2 to the power x, we could. So we need to get suspicious about two things. One, that they give us number 4 and 2 as bases, and 2, there's 3 terms in this equation. So that means it's going to be, or it could be, a quadratic. So let's see what would happen if y would equal 2 to the power x. Let's see if I can try and write 4 to the power x in terms of y. Well, if there's a plus in the power, that changes to a times when I split it up. And 4 to the power x, I can write that as 2 squared to the power x. 4 to the power 1 is just 4. I'm allowed to swap around the powers, so 2 to the power x squared times 4. I can swap around the powers, but it's just multiplication. Doesn't matter what order it's done in. So that's just y squared times 4, so 4y squared. So my whole equation turns into 4y squared minus 9y plus 2 equals 0. Then I can factorize that. So I'm going to do the AC method. So I'm looking for two numbers that times to make 4 times 2 is 8. So two numbers that times to make 8 and add to make minus 9. So that's going to give me minus 8 and minus 1. So I'm going to put 4y minus 8, 4y minus 1. And I need to divide that by 4 because I've got one extra factor of 4. So if I divide this one by 4, I get y minus 2, and 4y minus 1 is 0. So I get y is 2, or y is a quarter. Now, if you remember what y was 2 to the power x. So 2 to the power x is 2, or 2 to the power x is a quarter. Well, 2 to the power x is 2, means that x is 1. 2 to the power x is a quarter, means x is, well, it's going to be negative power to give me the 1 over, and 2 to get the 4. So 1 and minus 2.